The next topic is change of variables from Cartesian to polar coordinates. Okay. So we have to change the Cartesian coordinate into a polar coordinate. The question is evaluate integral 0 to 2 integral 0 to root 2x minus x square into x square plus y square dy dx by changing into polar coordinates. Usually in the Cartesian coordinate we have integrals like 0 to 2, 0 to infinity like that. But in the polar coordinates we will take from 0 to pi, 0 to pi by 2 like that. Okay. So now let us see this problem. We know the integration I equal to 0 to 2 integral 0 to root of 2x minus x square into x square plus y square into dy dx. Okay. So this is what given in the question. Now we can draw the figure. Okay. So this is your x-axis and y-axis. So this is our 0. This is x and y. And also we know that our first integration belongs to x. The second one there is no y. So this means that our next integration belongs to y. So first we can write the x equal to 0 and x equal to 2. Okay, so x equal to 0 lies on the y and this one is x equal to 2. Okay, so this is over. The next integration is 2x minus x square, which is in the form of a circle. Okay, we can say it is in the form of a circle. If you know that using this you can draw the circle here, or if you don't know you can just check before doing the problem and then you can draw the circle. So we can draw the circle now. From y equal to 0 it is going to start. So I am starting from y equal to 0, that is y equal to 0 line to this circle. So this is a Cartesian coordinates. So I am drawing a strip. Here our diameter is 2. So approximately our radius will be 1. So x equal to 1 and y equal to 0. X equal to 1 at the line, y equal to 0, and here we have 2 radius, x equal to 2. So I am going to mark this point as A. So x is 2 and y is 0 here. On this point we know x and y meets at 0, and this point is our y equal to root of 2x minus x square. This point is B. So first I am going to write the Cartesian form. Cartesian form is only given in the question. So we are directly going to write the Cartesian form. Our x equal to 0 to x equal to 2 and our y equal to 0 to y equal to root of 2x minus x square. This is what I have told you. So we are going to check whether it is the form of a circle. So we can write y equal to root of 2x minus x square, which is equal to y square equal to root of 2x minus x square. So we can write in the form of x square plus y square minus 2x equal to 0. So as you can see, this is in the form of a circle. So I am going to mark this as equation number 1. So using this equation only I have drawn the above figure. So it is in the form of a circle. Now what we have, the region of integration is OAB, which means and the figure it is connected with O, A and B. Okay, now I am going to start the polar form. To start the polar form, we know our x equal to r cos theta and y equal to r sin theta and dy dx is equal to r into dr d theta. Okay, this is the standard general form for polar coordinates. Okay, for instead of x we have to use r cos theta. If it is instead of y we have to use r sin theta. For dy dx we have to use r dr d theta. Okay, so this is the standard form. Whenever it is in the Cartesian form, when you are going to change it in the polar form, you should use this. Now let us write theta to theta, which means our polar form lies between the line 0 to pi. Okay, let us draw the figure. So the line lies between theta equal to 0 to theta equal to pi. This side is theta equal to 0. Okay, and this one is our half of the pi. So theta equal to pi by 2. Okay, so using the reference of the same image only we are going to draw. Our r is going to start from here, r equal to 0. Our r equal to 0 is going to start from here. So I am going to draw a circle starts from r equal to 0. So the polar form will be shaded like this in this region. That is our x equal to 2 cos theta. So this is the shaded region. So this connected region is A. What we have here, x is equal to 2. Okay, so that only I have written r equal to 2 cos theta, x equal to 2, so r equal to 2 cos theta. So this is a shaded region. So it is in the first quadrant from pi by 2 to 0. Okay, so r is equal to 0 to r equal to 2 cos theta. So this is the integration, second integration we have. The first integration is 0 to pi by 2 and the second integration is r equal to 0 to 2 cos theta. So the first equation is x square plus y square minus 2x equal to 0. Okay, this is in the question, the first equation. So instead of x square plus y square, So instead of x square plus y square, I am going to replace it as r square. Okay, minus 2 into our x is r cos theta. So our r is r cos theta equal to 0. So instead of x square plus y square only I have written r square. So we can write in the form of r into r minus 2 cos theta equal to 0. So r equal to 0 and our r equal to 2 cos theta. Okay, this is how, using this I have drawn this image. With the help of this only I have drawn this image. So it is advised to draw the image after solving the equation. After finding the r values you can draw the image. You can do it like this. So then only you can know it is 2 cos theta or not. Okay, hence r equal to 0 and r equal to 2 cos theta. So integration I equal to 0 to pi by 2 integral 0 to 2 cos theta r square into r dr d theta dr d theta. So how is this came? The question, as you can see, dy by dx is replaced as r dr d theta and r square is replaced from x square plus y square, which is given in the question. So x square plus y square is replaced as r square, and our the question, so this one x square plus y square is replaced as r square, and this part is our dy dx equal to or dr d theta. This is how I have replaced it. Okay, now we can write it as integral 0 to pi by 2 integral 0 to 2 cos theta r cube dr d theta equal to integral 0 to pi by 2. So first I am going to integrate this r cube dr. So r power 4 by 4 into r equal to 0 to cos theta, r equal to 0 d theta equal to integral 0 to pi by 2 r power 4. I am going to replace the value of r 2 cos theta by the whole square, whole power 4 by 4 minus this one is 0. So r power 4 by 4 will become 0 minus 0, the lower limit into dz d theta. So 4. No, wait. I'll explain. Integral 0 to pi by 2. How this 2 cos theta the whole power 4 is there, no? So we can write it as 2 power 4 cos power 4 theta by 4. Okay, into d theta. Okay, sorry, into d theta equal to integral 0 to pi by 2. 2 power 4 is 2 into 2 into 2 into 2 is 16 cos power 4 theta by 4. So this can be cancelled into d theta. So 4, we can take the 4 outside. Integral 0 to pi by 2 cos power 4 theta by 1. So into d theta. So this cos power 4 theta can be written as, we have seen one problem that if it is a cos power n theta and sin power n theta, if sin or cos is odd or even, so that we can replace the condition. We have one condition, right? So using the term, we are going to replace for integral 0 to pi by 2 cos power 4 theta with respect to d theta. So what we have, integral 0 to pi by 2 cos power n theta d theta. For this n, if it is a cos or sine, the same condition only. If it is even, then we have to write 1 by 2 pi by 2. Okay, the constant standard integration for cos power even theta. Okay, when n is even, we have to use this for cos and sine. Okay, so here we have the 4 into this 3 by 4. Integrating this cos power 4 will become 3 by 4, and cos power 4 integral 0 to infinity cos power 4 theta will become 1 by 2 pi by 2. Okay, that was replaced. So we have 3 by 4. This 4 will get cancelled. Pi by, that's all. So 3 pi by 4. So this problem is over. So now let us see one more problem similar to this. By changing into polar coordinates, show that 0 to infinity e power minus of x square plus y square into dx dy equal to pi by 4. So they have given the answer also. We have to show that the problem. And hence we also have to evaluate one condition, that integral 0 to infinity e power minus t square dt. Okay, this also we have to find. Now let's start the problem. I equal to integral 0 to infinity e power minus of x square plus y square into dx dy. Okay, so x equal to 0 and x equal to infinity. Similarly, y equal to 0 and y equal to infinity. For integral, both we have same only. So using this, we can draw the image. This is in the form of Cartesian form. This is given in the Cartesian form. After this, we have to find the polar form. Now we can draw the image. This is x-axis and y-axis. So you can see our x equal to 0 first. So x equal to 0 means this will lies on this line. So next one is x equal to, next y equal to 0. So your y is equal to, x equal to 0 here, and x equal to infinity will approximately lie somewhere in this line. Okay, so this is x equal to 0 and this is x equal to infinity, and next is y equal to 0, and for your y lines, y equal to infinity will approximately lies on here. Okay, somewhere here. Okay, so these are all the shaded region we have, and this is in the Cartesian form. So we are drawing a strip. Okay, now we can find the polar form. So polar form, our x equal to r cos theta and y equal to r sin theta. So dx dy is equal to r d or d theta, same to the previous problem. For all the polar coordinates we use this, and this is your 0 O. So for the region OXY, so it is in the form OXY. The joining points are OXY. So theta equal to 0 to theta equal to pi by 2, the first quadrant. Okay, the upper top right quadrant. So theta equal to 0 to theta equal to pi by 2, and r equal to 0 to r equal to infinity. Okay, so r also we don't know. So we can draw the image so that you can understand clearly. This is the polar form figure. Theta equal to pi, here theta equal to 0. This one is theta equal to pi by 2. And this one is x equal to 0. And next one, we are going to start the r. So r is equal to 0. It will approximately starts here. So it is in the polar form. It is up to infinity. So we don't know where it is going to stop. It will runs like this somewhere. So these are the shaded region, r equal to infinity. The shaded regions. Okay, we don't know where it is ends. So r is equal to infinity, from 0 to infinity. Therefore, I equal to integral 0 to pi by 2 and integral 0 to infinity e power minus r square into r dr d theta. Same, how we written this? E power rx is from e power minus of x square plus y square. So we already know our x square and y square is r square. So we can write e power minus of r square. Okay, this one is r dr d from dx dy. In the previous problem also we have seen. So a is equal to, we can split the integrals pi by 2 into d theta. So anyhow this theta is not going to work here because we have infinity only. So we can split the integrations into 2. So integral 0 to pi by 2 d theta into the next integral is 0 to infinity e power minus r square r into dr. Okay, now we have one important step here. So this is in the form of integral 0 to infinity e power minus u du by 2. Okay, so this is in the form, which means your r square equal to u. So your u equal to r square and du equal to 2r dr, and this is replaced as r dr equal to du by 2. Okay, so your u is r square and du equal to 2r dr and r dr equal to du by 2. Okay, integral, this we integrate it, what will happen, there is no theta, so it will become theta. So this theta is equal to pi by 2 to 0, theta equal to 0, and the next integration is integral 0 to pi by integral 0 to infinity e power minus r square. This r dr can be written as du by 2, right? This r dr can be written as du by 2. Okay, no, this is not necessary. So this is substituting our theta pi by 2 minus 0. So this is 0 to infinity e power minus r square. So this du by 2, what is du? Du is 2r dr, 2r dr by 2. Okay, so instead of du I have replaced 2r dr, the divided by 2 is there, which is equal to pi by 2, and this one is, we can take this 2 outside, so it will become 1 by 2 integral 0 to infinity e power minus r square into 2r dr. Again, what is 2r dr? This 2r dr can be written as du. Okay, so 2 dr can be written as du. So du. Okay, and also this u can be written as r. U can be written as r square. So for u is equal to r square. So here pi by 2, and we have 2 is here, so it will become 4. So we are going to integrate this now. So for u we have minus r square and e power minus r square by minus 1 in 0 to infinity. Okay, so this u is r square. So we can write one more step so that you can understand clearly. 1 by 2 integral 0 to infinity e power minus r square d into, for u is r square. So r square. So followingly this next step. Now we can write it as minus pi by 4 e power minus r square 0 to infinity equal to minus pi by, that one is also 4, e power minus infinity is 0 and e power 0 is 1 equal to pi by 4. Minus into minus will become plus, so pi by 4. This is our equation number 1. Okay, so up to this the answer is over. Now we have found the polar coordinates, but in the question, as you can see in the question, we have to evaluate integral 0 to infinity e power minus t square into dt. So we are going to find that. To find integral 0 to infinity e power minus t square into dt. Okay. So now let us find that. Equal to I equal to 0 to infinity integral 0 to infinity e power minus of t square is replaced as x square plus y square. Okay, so it will become x square plus y square into this dx can be written as dx dy. Dt is written as dx dy. So we have two different integration. We can split the integrations. Integral 0 to infinity e power minus x square dx. The next integration we have 0 to infinity e power minus y square dy. Okay, so we have two common similar integrations. So x and y are dummy, so we can replace it as t again. Okay, so integral equal to integral 0 to infinity e power minus t square dt, the whole power 2, because we have two integrations, so the whole power 2. Okay, now by using the equation number 1, we can see that our e power r square is the value, final value is e power minus r square r into dr is pi by 4. Okay, this is also similar to that one, so we can replace it as from form of equation number 1. So integral 0 to infinity e power minus t the whole square. So this can be written as pi by 4, this one, and the whole power 2. So we can write integral 0 to infinity e power minus t the whole square will become root of pi by root 4 is 2. Okay, so that's